In this lesson, we're going to look at two ways to produce or prepare carbon dioxide. In the first method, we're going to add a carbonate to an acid. So for example here, we've got some marble chippings, and marble chippings are made from calcium carbonate. Okay, so calcium carbonate is our carbonate, so to speak, and we're going to add those to a solution of hydrochloric acid. We've got a delivery tube here, and we're going to use the downward delivery method to collect the carbon dioxide. And the reason for that is that carbon dioxide is quite a dense gas. It will therefore push the air out of the test tube as it falls to the bottom of the test tube. Okay, so in this reaction, let's just write the general equation at the top here. And this is true for any carbonate and any acid. So we've got a carbonate plus an acid will result in a salt, and that depends on the type of carbonate and it depends on the type of acid that you use, plus water plus carbon dioxide. Carbon dioxide in this case is the stuff that we're after. Now you could demonstrate carbon dioxide's presence by putting lime water in this test tube and bubbling the carbon dioxide through the lime water. You'll notice that it turns a cloudy white colour. So let's write out the equation for this reaction. So we've got calcium carbonate. There are a lot of big words in this reaction, so I'm going to have to write it like that. Okay, plus hydrochloric acid, and the salt in this particular reaction, well, the calcium from calcium carbonate would join with the chlorine from hydrochloric acid to produce calcium chloride, plus water plus carbon dioxide. Okay, so we'll write out the symbol equation for this reaction. CaCO3 plus HCl, aqueous, that's a solution, hydrochloric acid in solution, gives us calcium chloride, aqueous, plus H2O plus CO2. And so let's just balance the equation. We can see there is a problem. We've got two chlorines on this side of the equation, one here. Likewise, we've got two hydrogens on this side and one here. Everything else is alright. So to balance it, all we've got to do is put a 2 in front of the hydrochloric acid on that side and everything's fine. Right, the other method that we're going to use to produce carbon dioxide is through the decomposition of a carbonate or a metal carbonate. When we do that, what we basically do is we just heat the carbonate. Now, a classic example really is one called copper carbonate. That decomposes quite easily under relatively gentle heating. So we're going to use that. This is copper carbonate and it's got this sort of bluish turquoisey colour. And as we heat it, you'll notice that the blue crystalline powder changes into a black powder. In doing so, it is changing into a substance called copper oxide. And while that happens, a gas is released, which is carbon dioxide, which we're after, and that's passed along the delivery tube and collects in the test tube. Again, downward delivery as before, because carbon dioxide is a denser gas than air, and so CO2 will collect here. So let's write out the word equation for this reaction. We've got copper carbonate. Again, reaction is a bit of a funny word really to use to describe this, because it's not really a chemical reaction at all. All we're doing is we're just heating a substance and it's breaking up, so it's not reacting with anything. However, the term is used. We do talk about decomposition reactions. So it breaks up into copper oxide, that's the black powder left behind in the test tube, and carbon dioxide. And we can also write out the symbol equation. So we've got CuCO3 for copper carbonate breaking up into CuO, copper oxide, plus CO2 carbon dioxide, aparo. And as you can see on inspection, that equation is balanced. We don't need to change anything there.